Okay, so back to having an equation. Unfortunately, it's an equation with trig in it. So we gotta dig deep. Alright, so they give you the velocity equation and they tell you a position at a certain point in time. So on the first one, we have to figure out when is the particle moving to the left? Or basically, when is the velocity negative? Right? So what we're going to do is we're going to figure out when is the velocity 0 and make a little number line and test points on the number line. So to figure out when this equals 0, I really have to figure out when is cosine 0 and then set this part equal to that. So if you think about your unit circle, only time that you can have 0 is on an axis. In the quadrants, the sines and cosines are not 0. So if I label these points like they would be on the unit circle has a radius of 1. So all of these points have 1s and 0s in them. And the first number is cosine and the second number is sine. So the cosine is 0 up here and down here at pi over 2 and at 3 pi over 2. So pi over 6t could equal pi over 2, or pi over 6t could equal 3 pi over 2. Those are the two times on the unit circle that cosine is 0. So if I multiply both sides by 6 over pi, I'll get t is 3 and t is 9, which are both in the interval that I'm talking about here. So at 3 and 9, the velocity is 0. So I'm going to pick something in each of these intervals. I'll pick 2, 4, and 10. To plug in here and see is this positive or negative. So between 0 and 3, if you plug 2 in for t, you get the cosine of pi over 3. Pi over 3 is in the first quadrant, and everything is positive in the first quadrant. This A stands for all. So we've got a positive there. If I plug 4 in, 4 pi over 6, that's 2 pi over 3. That's in the second quadrant where only sine and cosecant are positive, so cosine would be negative there. And then if I plug 10 in, 10 pi over 6, that's 5 pi over 3. That's over here in quadrant 4. In quadrant 4, cosine and secant are positive. So this would be positive. So it's negative between 3 and 9. So when t is between 3 and 9. So pretty trig intensive there. So that was worth let's see here. Let me find it. Proposition number 6. This was worth 2 points. 1 point for figuring out that you are looking at when when velocity is 0, which is at 3 and 9, and then for figuring out that it's between 3 and 9. So basically you had to have 3 and 9 in your answer, and you had to know t had to be between them. Did any of y'all get that one? Yeah, that one was, that was pretty bad. and for only 2 points. Okay, so part B, write but do not evaluate an integral expression that gives the total distance traveled from 0 to 6. And there's that total distance traveled again. To get total distance traveled, you have to integrate the absolute value of velocity. This was a point. Alright, so part C, find the acceleration at time t, and then tell if the speed is increasing, decreasing, or neither, and explain your reasoning. Okay, so to find the acceleration, we will have to take the derivative of velocity. So acceleration is the derivative of velocity. And to take the derivative of this, we have to use the chain rule. So we do the derivative of the outside. The derivative of cosine is negative sine. We leave the inside alone. Times the derivative of the inside. What would the derivative of the inside be? Pi over 6, right? The variable is t. So remember, anytime we take the derivative of a variable, it's just the number in front of the variable, the constant in front. So this would be pi over 6. So then we have, okay, so they want that equation. So negative pi over 6 sine of pi over 6 times t. So that's our acceleration equation. So then it says, is the speed increasing, decreasing, or neither at 4? So to figure that out, we've got to find the acceleration at 4 and the velocity at 4 and see if they have same signs or different signs. So the velocity at 4 and the acceleration at 4. So velocity at 4, if I plug 4 in, I get the cosine of pi over 6 times 4, which is the cosine of 2 pi over 3. And if I plug into acceleration, I get negative pi over 6 times the sine of pi over 6 times 4, which would be negative pi over 6 times the sine of 2 pi over 3. And all we care about really is, are they positive or negative? I don't really care about the actual values. So 2 pi over 3, what quadrant would that be in of our little unit circle quadrant up here? So if you think about it, this is 0, this is 1/2 pi, this is 1 pi, this is 3/2 pi, and this back to 2 pi. So if I just look at the fraction 2/3, where would 2/3 be? Between 0 and 1/2, 1/2 and 1, 1 and 3/2, or 3/2 and 2. It'd be in the second quadrant, right? 2/3 is less than 1 because 1 would be 3/3, but it's more than 1/2 because 1/2 would be 1.5/3, right? So it's more than 1/2 but less than 1. So it's in the second quadrant. So the cosine's going to be negative. The sine will be positive, but we're multiplying it by negative pi over 6, so that makes this also negative. So since they're both negative, speed is increasing because velocity and acceleration have the same sides. That was worth 3 points. 1 point for finding the acceleration equation, and then 2 points for determining that the speed was increasing because they have the same sign. So I think you would get 1 point if you just said it was increasing, and 1 point, 2 points if you included your reason. Alright, and then part D, find the position of the particle at t equals 4. So we've talked about this. To get the position, we would have to have where we start, which is at -2, plus the total change in position from when we started, which was 0, to when we want to know the position, and we integrate this velocity function. So really, if I just figure out what this is, and add it to -2, I'll get the answer. So to integrate this, what do I have to use? I have to use U substitution because I have one function inside of another one. The inside function is what I'm going to call U. So U is pi over 6t. The derivative of that is pi over 6, which we don't have on the outside. We don't have a pi over 6. So we have to give ourselves a pi over 6 and balance it with a 6 over pi. So we're going to get 6 over pi times, if you integrate cosine, it becomes sine of the inside from 0 to 4. The pi over 6 and the dt go away because they're part of the derivative, and the derivative goes away when we integrate. So we get the derivative, we integrate the outside, we keep the inside, we keep the u, and then from 0 to 4. Okay, so 6 over pi times, all right, we're going to plug 4 in, and we're going to get the sine of 2 pi over 3 minus, when we plug 0 in, the sine of 0. Alright, so to figure out the sine of 2 pi over 3, we know it's positive. We've already talked about that 2 pi over 3 is in the second quadrant where sine is positive. If you draw your really big square root, and this goes for your first quadrant, the sine of a pi over 3 angle is square root of 3 over 2. So this would be 6 over pi times the square root of 3 over 2. The sine of 0 is 0. The sine of 0 is 0, so we don't have to worry about that. And then don't forget you've got to add this to -2. So it's -2 plus this. So it's -2 plus, you can reduce this if you want to. They don't count off if you don't reduce. 3 square root of 3 over pi. So -2 plus 3 square root of 3 over pi. And that was worth 3 points. 1 point for integrating this to get this. 1 point for using the -2, and 1 point for getting down to the final answer where you plug in the 4 and the 0. So how'd y'all do on that one? That was pretty hard. Nothing.
I got 2 points. I got all of them halfway.
Yeah.
I got there and then not finished. See, I just couldn't finish it.
Yeah. Yeah. But hopefully you're starting to remember the total distance traveled.
Yes.
Yeah, absolute value of velocity.
Yeah,
Because that was easy points on that one, especially since you didn't have to evaluate it.
that's good.
Alright, so I think we worked all the velocity position ones. The only other one is that one from 2008, but that was on your take-home test. So, there's one slope field problem in here, the 2008 number 5. So you might try that one since we've been talking about slope fields recently. And then one type of problem that shows up every year was number 2 last year. It was number 3 the year before that. It was number 4 the year before that, number 4 the year before that. We're going to go number 1 the year before that. We're going to go over that type of problem this week in class. It's on there every year without fail, so it's like guaranteed to be on there. And then there's really one other type of problem that shows up pretty often, and we'll talk about that one, and then we'll talk about that one next Saturday, and then we'll kind of fill in with some of the other, you might see this type of problem kind of thing. But I think if you go and watch the videos online, if you've missed some of the review sessions and stuff, that you'll be in a pretty good place. So, are y'all feeling better about it?
Not yet.
Not yet.
Not yet.
Yeah.
The trig kills us.
The trig. Yeah. Yeah, they're mean.
That's